4.2.1 part 2. You might recall we had this pizza problem where we determined how much we should charge for a 2-topping pizza. It was something like $7.74 for a cheese pizza with no toppings and $1.36 for each additional topping. And then what we did was we decided that residual plots, we were looking for a pattern or not. So here was a pattern, so it wasn't a line. Here there was no pattern, so we said it was a line. And here we had a pattern, so we said it wasn't a line. And again, they matched with the appropriate graph. And hopefully you can kind of see how they go together, where it scatters here and it scatters here, and then it kind of curves here and it kind of curves here. And this is just sort of randomness. So that's just where we left off at. So it says, help Julia analyze the residuals for the pizza parlors in problem 479 as described below. Mark the residuals on the scatter plot you created in problem 449. If you want to purchase an inexpensive pizza, should you go to a store with a positive or negative? And we talked about this in the last video. We said a negative residual would actually be cheaper. So let's go ahead and take a look here. Here's one of the nice things about Desmos. If you want to plot the residuals, you just literally press plot, and there's your residuals. And this is your residual plot. It basically, again, you had one barely above the line. So now the x-axis and this line are essentially the same. They've just been tilted down. So it's barely above, then it's above by a little bit more, then it's below and below again, and then above and above. And you can kind of see how that sort of transpires, and you can see the correlating points. So again, we talked about this in the previous video, that this was the cheapest pizza in terms of what you expected to pay. It wasn't actually the cheapest pizza, but in terms of what you expected to pay, it was, right? So actually the cheapest pizza ended up being slightly more than you would expect to pay, apparently by 26 cents. And then this one, $1.97 more than we expected to pay, and you can see it's right there. It was $16.50, but it was $1.97 more than we expected to pay. So that, again, pretty simple to just hit residuals and go down to the x-axis. But how do we do it in our calculator? And you'll notice that I still have the old data in. I left that in, so we still have all of our information. So if you want to run a residual plot, the first thing you need to do is calculate the residuals, which makes sense. And if you want to calculate the residuals, the first thing you need to do is calculate the LSRL, which I've already done in the previous video, and I left it in there. But again, the reason that you have to do this is because this is the prediction line. And residuals compare your prediction to the actual. Well, if there's no prediction because you didn't run the LSRL, it can't tell you how much you missed by. So anyway, we've already calculated the LSRL, so we're going to go into the table. We'll hit stat 1 to go into the table. It says choose a new column. Again, I need to go to the top of that column where it says L3, not in the first row at the top. And I'm going to hit second list. And choice 7 is a residual. And again, if you didn't run the LSRL, choice 7 will not be residual. We hit enter. It's given us all the residuals. There we go. There's that pizza that was $1.97 more than we expected to pay. There's one that was $2.80 less than we expected to pay, etc. So you can see those residuals. So we've gone through and checked the residuals. So now we're to this point. Again, we've already calculated the residuals, so we're going to go to second stat plot. So we have to define. Second stat plot is where we define our graph. We're defining our graph. And it says change your Y list to the residual list. Well, if you'll remember, my residual list is an L3. So I'm going to change this to L3. Then I'll graph it. And then I'll go zoom 9. And it will give me my residuals. And you can see that my residual plot is very similar, right? So whether you want to do it in Desmos or in the TI-84, again, it's a lot faster in Desmos. Although I think, I don't know, in some ways you get a better look. Long story short, let's go ahead and judge this. Do we think this is random scatter? I do. I don't see much of a pattern there. So I would say that a line is a good fit, even though, you know, it's not perfect. I think a line is a good fit for that data. All right. So what's the sum of the residuals? Okay, so what is the sum of the residuals? That's going to be a lot easier to do here because I already have all my residuals here, right? So if I'm going to sum this, hopefully you'll know, I'm going to go to calc, one variable stats, and I'm going to add up L3. And essentially what I'm saying is I want you to do a bunch of numbers on L3, and look, the sum of my residuals equals 0. And is that really surprising? I would argue it's not. I mean, you're trying to draw the line down the middle, so it makes sense. Excuse me. It makes sense that your misses to the top and then misses to the bottom would be similar. So I'm not surprised by that result. So make a residual plot using your calculator. Okay, we've already done that. We've already interpreted it. So I think I went out of order. I should have done B first, but I did C first. So again, we decided a line is a good fit here because we thought that the data was pretty random in the residual plot, not to be confused with the scatter plot. All right, so we have new data. It says dry ice, frozen carbon dioxide, has the unusual property of sublimating or changing directly from a solid to a gas. Julie's father uses dry ice to keep glasses in the restaurant cold. Since dry ice sublimates in the restaurant cooler, Julie was curious to how long a piece of dry ice would last. She collected the following data. So we're going to make a scatter plot in the LSRL. And then we're going to use our calculator to make a residual plot, and we're going to determine if we think the line's even a good fit. At that point, obviously I'm going to go second memory, 7, 1, 2, clear my data, and then I'll just start putting in my L1, L2, and I'll spare you that. Data in, and I'm just going to go through the entire process on the TI-84, and then I'll bounce over to Desmos. So first thing I'm going to do is go stat, calc, linear regression. I will go to store reg to take the shortcut of saving the equation for me. So vars, y vars, and I'll save it in y1. And I get the equation, which I will jot down. Y equals negative 0.52x plus 15.21. Now I will go define my stats plot by going L1, L2, and I will go zoom 9 to take a look at it. So here's what my data looks like. And again, what does this mean? So I am going to remember my X's are hours afternoon and my Y is weighted dry ices in ounces. So if I look here, again, my X is hours afternoon and my Y is weight of dry ice in ounces. And I have an equation, Y equals negative 0.52x plus 15.21. So I never want to lose sight of the fact that I always want to figure out what this equation means. So I have negative 0.52 y's, right? Remember my slope is change in y over change in x. So negative 0.52 ounces for every 1x for every hour afternoon. That makes sense. So every hour afternoon, I lose 0.52 ounces of dry ice. And what about my y-intercepts? If I have 0 hours afternoon, meaning how much ice I started with, I started with 15.21 ounces of dry ice. So that makes a lot of sense. All right. Again, it doesn't ask us to do this, but I always want us to do this. I always want us to know what we're talking about because I think it makes everything more clear when we look at it. So when we look here, hey, I started with 15.21 ounces and I am losing essentially a half an ounce every hour afternoon. All right, now I'm going to go ahead and do my residuals, or my residual plot. The first thing I have to do is my residuals. So I'll go to the top. I will go second list and choose 7. This gives me my residual. So you can see here I had more dry ice than I expected. Here I had less dry ice than I expected. And I will, by the way, real quick before I run the residual plot, that looks pretty good, right? I mean, it looks very linear. But here's the beauty of a residual plot. I'm going to change it from L1 to L3 because remember my residuals are now in L3. And I will go zoom 9 and look at that. A very clear pattern. So ironically, this data, and by the way, I'm going to just say I have the data in Desmos right now. This data, a line is not a good fit, which is crazy because it looks like a line is such a great fit. But when we look at our residual plot, we can see it should be a very slight curve instead. It would make more sense to make it a slight curve. As a matter of fact, if you don't believe me, if you look at the residual plots, you can see positive, positive, and then it goes negative, 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 negative. And then it goes positive, positive again. So you can see we definitely have that distinct pattern. All right, so what if we had done the whole thing in Desmos? I'll go y1 tilde mx1 plus b. You can see I get that same equation right there. Y equals negative 0.52x plus 15.2. Again, you can really begin to see my actual are above the line, then I go below the line, then I go back above the line. But if I want to see the residual plot, I'll just click that. Doesn't look like much right there, but what if I zoom in on it? And you can see, by the way, I can even change my scale on this, right? If I want to change my Y to go from like -1 to +1, it becomes way more pronounced. So you're allowed to change your scale to look at the residual plot if you want to. And you can see, again, we're coming to the same conclusion that a line is not a good fit. Ironically enough, it looks so good up here, right? But a line is not a good fit because we see a pattern in the residual plot. Alrighty, so moving along. We get to a fabulous question in 4.53, so let me set this up. Question 453, a lot of kids get really confused with what's going on with this question, but I think it makes sense if you kind of go with it. So, a study by one state ag commission plotted the number of avocado farms in each county, against the county's population in thousands. So again, that's in thousands. It's the population in thousands. And you'll notice this is a residual plot. This is not the scatter plot, okay? And they give us the equation. F is the number of farms. P is the population in thousands. So 3.96 times whatever the thousands of population is plus 9.37. And that'll tell you how many farms they have. So if you think about what this equation says, again, we're saying 3.96 Ys, or output is farms, 3.96 farms for every 1,000 population. And that makes sense. The more people live there, the more farms you'd want. So again, my slope is change in y over change in x. Hopefully that makes sense in context. And my y-intercept tells me if I had 0 population or 0,000 people, I would have 9.37 farms, or 9.37 avocado farms. So just in context, making sure that we're all okay with what this LSRL is telling us. All right, so do you think a linear model is appropriate here? Again, this is a residual plot. I'm not really seeing a pattern, so I'll say sure, no pattern, equals line. It says, what's the predicted number of avocado farms in the population? 62,900. Well, 62,900 is right here, right? Well, remember, this tells me my misses. It doesn't tell me my actual. I need to plug 62,900 in here, but I'm not actually going to plug 62,900. I'm going to plug 62.9 because it's in thousands, right? So I'm going to go here. I'm going to grab my calculator. And I'm going to say 62.9 times 3.96. Again, my slope is 3.96. My starting is 9.37. Like I said in stats, a lot of times they change us around. Plus 9.37. So my prediction is there should be 258 farms. For a town that size. So using the residual plot, how many farms were there actually? Well, this number right here, where this line hits, is my prediction. It's 258. Uh-oh, I put one too many fives there. It's 258. So you can see my residual it looks like it's like -18. So there's actually 18 less than there should be, or 18 less than I predicted. So there's only 240 farms about. I really think this is a great question to help you understand what a residual plot is and how you can use it and how it works backwards and all that good stuff. So hopefully you didn't miss what just happened there. All right, so it says Sophie and Lindsay were discussing what it meant for a residual plot to have random scatter. Sophie said that the points need to be evenly scattered over the whole plot. Lindsay heard her dad say the stars in the sky can be considered to be randomly distributed, even though the stars sometimes appear in clusters and sometimes there are large expanses of nothing in the sky. Use your calculator to make a scatter plot with random points on it. I'm not going to do that, but essentially we're supposed to be making random scatter plots, and I'm just going to kind of read what the book says the answer would look like. So if we had grabbed our calculator and had made a random scatter, points are not evenly scattered around the plot. Points can be in clusters, and there could be large gaps. However, there's no discernible trend or pattern. And again, if we look at this, we can see this is the one that we said had no discernible pattern. Well, clearly, there's some clusters here and some gaps here, but there's still, essentially what I'm saying is if you told me something landed on the left, I would have no idea what to expect. If it landed in the middle, I had no idea what to expect. If it landed in the right, I would have no idea what to expect. That's kind of what we're looking at. All right, that wraps up 421.